everyone, welcome to APS Deep Academy and this is your mentor Swati Joshi. In this class, we will study about common emitter configuration of transistor. Common emitter configuration is also considered as transistor as an amplifier. In this circuit, we can see that emitter terminal, which is nothing but this, is common in input as well as output characteristics. So this is our base and this is our collector and this is our NPN transistor. Now we can see that this VBB battery is making forward bias to base emitter junction and this VCC battery is making reverse bias to collector emitter junction. We know that in NPN transistor base terminal we have P-type impurity which is positive in nature, and in collector and emitter we have N-type impurity which are negative in nature. So positive connected to positive in case of VBB, so this is forward bias, and negative connected to positive in case of VCC as in case of collector emitter junction, so it is reverse bias. Now as a part of working, what is happening here, due to this battery, this IB current is flowing inside the circuit and this is reverse bias. So only this current which is flowing toward the base is coming to the emitter because the VCC battery is making collector emitter junction reverse bias. So in reverse bias, we know that in PN junction no current will flow. So here the current is flowing towards base and towards the emitter with the help of this VBB battery. Now here the collector current, we know that this is the positive and it is connected to negative of the collector. So this negative is flowing towards, the negative electron is flowing towards the battery positive. So electrons are moving in this direction. So according to the movement of electron, we know that current will flow in opposite direction. So this is the direction of IC current. So here we can see that the terminology which is nothing but IE is nothing but IB plus IC is following. Okay, we can see that IE current is flowing in this direction and IB or IC is coming towards the transistor circuit. Now we can see that IB plus IC is nothing but our IE. So this is fulfilling. So this is the proper working, proper understanding of how this circuit is working. Now what is happening in this circuit? We are giving sinusoidal as an input signal, sinusoidal waveform, and in output what we are getting the same waveform but 180-degree phase reversal and higher in amplitude. So whatever the amplitude is here is higher in nature in case of common emitter configuration. So it is working as an amplifier because the low amplitude signal is converted into high amplitude signal. Here one thing we can see that the frequency of oscillation of input signal is same as the frequency of oscillation of output signal, but only the amplitude is changing. So this is 180-degree phase reversal and amplitude is little higher. So this is the basic understanding of how this common emitter circuit is working. Now we will discuss the input and output characteristics of common emitter configuration. This is the input characteristic curve of common emitter configuration. In this, we can see that in horizontal axis, we have biasing voltage, base emitter biasing voltage, which is VBE. And in vertical axis, we have IB, which is base current, which is in microampere. Now here, VCEs we are making constant for 1 volt and 10 volt. So, and this is our knee voltage, which is nothing but the pinch off voltage or starting or operating voltage for the junction. Now here we can see that current is increasing exponentially. So this is simply resembling the PN junction VI characteristic graph. In this also the current is increasing exponentially after it will attain a particular pinch off voltage, which is nothing but the 0.7 in case of silicon. So here also same thing happened, current is increasing exponentially. So in input characteristic, the input portion is behaving, the base emitter junction is working in forward bias and behaving like a PN junction diode simply. The current is exponentially increasing with the voltage. Now here what is happening? If I compare this graph, this is of CE, and if I compare this graph with CB, in CB what is happening? In input characteristic of common base, what is happening? The current is increasing like that. It means the increment of current, the exponential increment of current is little higher. So here we can see that in common emitter what is happening? This is in common emitter, the current is increasing gradually, although it is exponential increase, but it is increasing gradually. So what is happening? The resistance in common emitter, the input resistance in this common emitter configuration is little higher than the common base configuration, because in common base the current is increasing rapidly, but in common emitter current is increasing little gradually or little less rapidly in case of common emitter. So the input resistance of common emitter is higher than common base. Okay, so from this diagram we have two findings. One, that input characteristics are nothing but the VI characteristic of PN junction working in forward bias, so current is increasing exponentially. And the second one is that the input resistance of common emitter junction is little higher than the common base configuration. It means it can handle more more intensity signals. Okay, now we will discuss the output characteristics of common emitter configuration. This is the output characteristic graph of common emitter configuration. In this we can see that we are making IB, which is nothing but the base current constant for 5, 10, 15 and 20 microampere, and according to this we will get IC, which is nothing but the collector current. It is in output. So in vertical axis we have the output current IC, and in horizontal axis we have biasing voltage of collector emitter, which is VCE. Now what is happening, if we are considering IB constant at 5 microampere, then the current increment in IC is till 1 milliampere. Okay, and after that it is become steady. Similarly, for IB 10 microampere, the current increment is 2 milliampere, and after that it is steady. Similarly, for 15, it is IC is increased 3 milliampere, and after that it is steady. And similarly for 20 microampere also. It means if we are increasing the base current, the IC is also increasing. So IB and IC are directly proportional. So IC is proportional to IB with a factor of beta. Okay, with a factor of beta. So what is happening here, the output current, which is IC, and the input current ratio, which is nothing but IB, it is nothing but the current gain or beta. Okay, this is our current gain, output current gain, which is nothing but the beta. This is our output current and this is our input current. So IC upon IB is beta, which is current gain, output current gain. Okay, now here one thing we have to notice, the input current, which is base current, is it is in microampere, and output current, which is output current IC, it is in milliampere. It means if we are giving base a light amplitude signal or less amplitude signal, the output is converting into a higher amplitude signal, because the current here, it is in microampere in case of base and in milliampere in case of IC. So the increment is like that only. Base current is minimal and the collector current is maximum. So what is happening here, the current is amplifying in a particular manner. So from figure also we see that, from circuit diagram we also see that current is amplifying in a particular manner. If base current is in the value of microampere, the collector current, which is output current, it is in the value of milliampere. Okay, from circuit also we see that how base current is less because of the less charge carrier in the P region of NPN transistor or base region. So base current is less. According to this, the collector current is very high. Okay, so this is the output characteristic of common emitter configuration. Now we will discuss beta here, which is nothing but the current gain. So let us discuss beta here. So IC upon IB is nothing but the current gain, which is nothing but beta. Okay, now here some relation is between alpha and beta. In common base, we consider that current amplification factor, which is alpha, which is nothing but the IC upon IE, collector current upon emitter current, which is in common base configuration. So alpha is IC upon IE. From the equation, the basic equation, we know that IE is nothing but the addition of collector current and base current. From this, we will conclude our lecture with the with the relationship between beta and alpha. So if we divide this by IC, this is our basic current equation. So if we divide it with IC, what will happen? What will happen here? We can see that IE upon IC is nothing but 1 upon alpha. Okay. Now IC will cancel out. So this is 1, and IB upon IC is nothing but 1 upon beta. Okay. Now if we take LCM and do few further calculations, what will happen? 1 upon alpha is nothing but beta plus 1 upon beta. Okay. If we do cross multiplication, what will happen? After cross multiplication, we will get beta is nothing but alpha into beta plus 1. Okay. So Similarly, if I have to talk about the relationship between beta and alpha, what is happening? Beta is nothing but alpha beta plus 1. So alpha is nothing but beta upon beta plus 1. So this is the relationship between alpha and beta. Alpha here is current amplification factor, which is nothing but in common base configuration, okay, current amplification factor, and beta is current gain in common emitter configuration. So this is the relationship between beta and alpha of common emitter and common base, okay. So common emitter is considered as transistor as an amplifier. Why so? Because it can amplify the base current, and an output we will get the higher collector current, okay. And this is the relationship between the common base and the common emitter alpha and beta. So for today this is much. We will see you in next class. Thank you so much.